Okay, is my screen visible to you guys?
Yes, Sisira.
Guys, is my yeah.
Yeah.
So okay, let's revise our previous session. So this integration runtime, we know that integration runtime is nothing but it's a compute infrastructure used by the Azure Data Factory. So there are three types. So based upon your necessity, you'll be using one among them. When will you go with this Azure or Auto Resolve integration runtimes? Anyone?
Azure Auto Resolve.
Yeah,
Anything with the cloud environment
yeah. If you want to move the data
between
between
the
the
cloud.
clouds, yeah.
Yeah.
And self-hosted, if you want to move the data from any on-premises or any virtual private network, you'll be using the self-hosted integration runtime. This we should set up this manually, whereas the auto resolve integration runtime, it will be directly provided by Azure to us whenever we create this Azure Data Factory. And coming to the SSIS packages, sorry, SSIS integration runtime, to execute the SSIS packages on Azure, we'll be using this SSIS integration runtime. And Azure Data Lake, we have discussed that. So whenever you're dealing with big data, you'll go with the Azure Data Lake, since it supports storage of structured, semi-structured, and structured data. And so why in case of big data we are going to this is because it is designed on top of Hadoop distributed file system. That is, it will be having distributed processing. So yeah, that's why we'll be going to this Azure Data Lake for big data when we are dealing with big data. And these are the two versions: Data Lake Gen 1 and Data Lake Gen 2. Uh, the current version is the Data Lake Gen 2. We are everyone will be using this only. So by taking the advantages of Blob and the Gen 1, they have created this Gen 2. And these are the difference between Blob and data lake storage. So one of the main differences, so whenever you want to if your requirement is to store the data in form of folders, subfolders and all, then you'll be going with this Azure Data Lake, because here the hierarchical namespace is not present in the Azure Blob Storage. You won't be able to create the subfolders inside a folder. So coming to security, so in Azure there are three ways in which it's providing Azure is providing security to an Azure storage account. First one is access keys, uh, and the second one is through this shared access signatures. Sorry, the second one is this IAM. Sorry, this role based access control. Yeah, first one is this access keys. The second one is role based access control, and the third one is the shared access signatures. And one more thing, Ravi, you have asked me, no, like why are they providing these two keys?
Correct. Yeah. That's right.
Yeah. So I have done some POC on it. So what's the thing is, they did not tell us directly, but the thing, like what I came to know is, so whenever a storage account gets created, there'll be two keys generated automatically. So what happens
Okay.
is, this key one will be hosted on separate data center, and key two will be hosted on separate data center. So in order to provide us the high availability, so in case
Oh,
if one data center goes down, then the key one goes down, so that you can use the second key. So in order to make sure the high availability property satisfies, they are using this two keys concept,
okay. That makes
just to
sense now.
make the
Thank you.
resources highly available. Yeah.
Okay. Okay. Thank you.
So as far as I have I have gone through few articles, and so that's what I came to know.
Okay. Okay. That's brilliant. Thank you, Cecily. I appreciate that.
Yeah, yeah, that's all. So when to use the shared access signature? So if you want to provide only few restricted access to any few users, then you can use the shared access signatures, wherein you'll be giving the access only to few services, so only few permissions. So based on that, you will customize your uh, access, and then you'll be providing that URL to the user. Yeah. So this is all about day 7. That is our previous class. Now let's move to today's class. So today let's see the data warehousing concepts. So actually, I thought of taking this on Saturday, but Visualpath, due to some technical issue, they couldn't host this go to. So that's the reason it's today we are taking this. And next Monday, that is on 20th, then I'll be taking holiday. So 18, 19, 20, there'll be holidays. You can plan accordingly. 18, 19, 20. If you want to go anywhere, you can go. Yeah, I'm sharing this. So people who know this data warehousing concepts, you guys, it's just like a brush up for you. Yeah, 1 second. So yeah, is my screen visible to you all? I'm presenting this data warehousing concepts document.
Yes.
Yeah. So coming to see, as a data engineer, it is necessary for us to know all these concepts because in our day-to-day lives, everywhere we'll be using anything. We'll be working on these only, knowingly or unknowingly. These are all the things on which we work daily. So that's the reason I'm telling you. And also in interview perspective, also they'll be asking you like what are the schemas which your project is using. And regarding these dimensions also, like what are the dimensions you have, and so that's why we are dedicating a class for it. Okay, yeah, let's start from basics. So what is a data warehouse? As we discussed, so basically it will be maintaining the historical data, and it is an OLAP, that is it is used for analytical purpose. So let's discuss in detail like what is this data warehouse. So what happens? We will collect the data related to different subjects in the data warehouse. What subject oriented? What is the meaning of subject oriented? Is this data warehouse holds the data related to different subjects. For example, if we take sales, HR related information, finance, inventory, all the information related to customers and services, etc. So all these different subjects, so each one is a different subject, like customer related information is a different subject, inventory is a different subject, sales is different subject, and finance is different subject. So here the data is of different subject. So that is what is the meaning of subject oriented. So data warehouse is subject oriented and integrated. So what do you mean by this integrated is it integrates the data from multiple data sources. So we can see if it when we have discussed that ETL architecture, what are we doing? We are extracting the data from multiple sources. So in data warehouse, we'll be keeping the data which is coming from multiple sources. That means we are integrating all the data from the multiple sources and putting it into a single destination called as a data warehouse. And also time variant. So what do you mean by this time variant is you can segregate your data based on time, like what is 3 months, previous 3 months of data, past 6 months of data, and past 12 months of data, like that you can segregate based upon the time. So that is meant by time variant. And coming to non-volatile, as we have discussed that only historical data will be present in the data warehouse. So whenever the data is historical, we are not supposed to change that data. That is, the data doesn't change, and it should also never be changed. So any historical data, we are just maintaining it for the analytical purpose, so we are not supposed to change and it won't change. So that is the meaning of non-volatile. So It's a subject oriented, integrated, time variant, and non volatile collection of data in support of management decision making process. So this is the definition given by Inmon. Yeah, okay, is it clear? So basically for freshers, you guys should know this. And yeah, so coming to data model. So why, what is this data modeling is? So we have discussed that a data warehouse, something is said to be a data warehouse if it follows, if it satisfies all these properties. So in order to support all these properties, we need to have a different table structure, so different table design, so that it will be able to what do we say, this it will be able to satisfy all these conditions. Yeah, satisfy. So it will be able to satisfy all these conditions. So the way in which you define the table structure is dimension modeling. So we'll define that as, we'll call it as a dimension modeling. So in dimension modeling, what happens is you will be having the fact table in the middle, and this fact table will be surrounded by all the dimensions. So every database will have a data model. Data model. So what is this data model is? We'll have tables. So what is this data model? In the data model, we'll have tables. Tables will have columns, and the columns will have the primary key. I mean, the columns will be few columns will be the primary key columns, and few columns will be a foreign key columns. So we will be establishing the relationship between the tables using this foreign key and primary key columns. So for example, yeah, this is the example. So what I have told you, that integrated. So the data is being integrated. That is, even if the data is from different sources, you are combining it into a single. So for this, we'll take an example. That is, if we take a Reliance Trends and a Reliance Retail, these are the two ERPs. So Reliance Trends will be maintaining a separate ERP, and for Reliance Retail, it will be having a separate ERP. So what happens for Reliance Trends? This ERP will have these separate tables. Like it will be having the customers table, product table, and sales table. And this ERP, Reliance Retail ERP, will also be having these three tables. But here Reliance Trends is having a separate ERP, and this is having a separate ERP. But so Reliance is a big company, but this Reliance Trends and Reliance Retails, what are these are the subsidiaries of Reliance. So what happens when we take this database, so sorry, data warehouse. So in the data warehouse, this is the Reliance warehouse. So in Reliance data warehouse, what happens here? So at a total, this is at subsidiary level. Reliance Trends will be having separate tables, and Reliance Retail will be having separate tables. But Reliance at the top level will be having only single customer table, single product table, and single sales table. So what is happening here? The customer table from the Reliance Trends is stored in all the customer information in the Reliance Trends ERP will be stored in this customer table, and all the customers information from Reliance Retail ERP will be stored in this same customer table. So what is happening here? Here they are different, but the data is combining into a single table. So that are integrating. So what is happening here? Here the customers are I mean, they are different. They are defined on a separate basis, and here they are defined on a separate basis. But coming to a data warehouse, you are integrating the data. So here there will be only a single customer, and these tables also, there will be a single tables. Okay, Reliance at the top level, at an organization level, it will be having only single tables in the data warehouse. So what are the steps in designing a data model? So first step in designing a data warehouse is to build a conceptual data model that defines the data you want and the higher level. So see, when you are building a software or a database, what happens, you'll be having a lot of data, but you won't be taking all of that data. You will be selecting and taking only the data which is necessary for you to process, and that which is used by the business and which is needed by the business. So the first thing what you'll do is, first you will select like what is the data which is necessary, and then you will also try to establish a relationship between them. And so that is the reason we'll be having this all data model, and the data model which we use is this dimension modeling. So in this dimension modeling, what happens is, we will be having two kinds of tables. One is fact tables and the other one is dimension tables. So what is this? Did you guys understand this? What these two? What is a data warehouse and data modeling?
Yes. Thank you.
Yeah. So why do we need to model the data? Is since we want to design a database, we need to know like what are the tables which we want to use and what is the relationship between them. So to know those things, we'll be modeling the data. And yeah, so what are these dimension tables? So since I have told you that we'll be having two types of tables, that is dimension tables and the fact table. So what is this dimension table is that? Hmm. So this dimension table will be having the master data. So what do you mean by this master data is, for example, you have an Amazon account. So whenever you one like when you open this Amazon account, I mean when you create this Amazon account for the first time, you need to enter the details like your name, address, phone number, email ID, etc. So all the details which you enter, these details come are considered to be the master data. And the transactions you do, that is the orders you keep and the transactions you do, come under the fact data. So simply, dimension tables contain the master data, and the fact table contains the transactional data. So these are all like I mean, if someone asks you what is a dimension table, so dimension, what do you mean by the word dimension is the details. So the definition of dimension is it's the details. So a dimension table contains the dimensions of a fact. Since I have told you that fact, what does a fact table contains? It contains the transactions. So here it is defined that a dimension table contains the dimensions of a fact. Dimensions in the sense details of the fact table. So this dimension table will contains the details of the transactions which you have made. So that is what it is written here. So the dimension table contains the dimensions of a fact. So they are joined to a fact table via foreign key. So whenever you want to establish a relationship between the two tables, what you will use, you'll use the concept of foreign key to establish the relationship between them. So these dimension tables are denormalized tables. So normalization and denormalization, you know those concepts, no? So in order to reduce the redundancies and all those, we'll be using the concept of denormalization and normalization. So the dimension attributes
Uh,
are various columns. Yeah,
Shisha, once again, can you please once again explain about that foreign key?
foreign key. Yeah.
Yes.
Yeah. So
What is that?
whenever you want to establish the relationship between the two tables, um, okay, let me tell you. So what happens is, for example, we have a product table wherein we have the product ID, product name, and we have the orders table wherein we'll be having the product ID. quantity. So what see, we are having two tables. One is the product table and the other one is the orders table. So what I'm doing is, so whenever you purchase any product, what happens is in the orders table a transaction gets created. So what happens here, instead of maintaining all the details of a product again in this order table, what you will do, so in this product table, product ID is the primary key. So here, instead of maintaining all these details again in the order table, what you will do is you will just keep this product ID. That is the primary key in this product table is again kept in this table. So here this becomes the foreign key. So what is foreign key? So anything. So if we present in India go to the other country, we will become a foreign person. So what is happening, we are actually the residents of India, but we are going to some other country, there will become the foreign person. So in the same way, this product ID is actually the column which is of this product table, but to to establish a relationship between these two tables, this primary key which is the product ID, we are picking this product ID which is a primary key and placing this in the orders table. Why? To establish the relationship between these two tables. And why we are establishing the relationship is in order to reduce the redundancy. So instead of maintaining all this data once again in this orders table, we are just selecting the primary key and putting the primary key here. So now this product ID here will become the foreign key.
Yeah, okay, sister. Got it.
Okay. Yeah. So why this foreign key is used to establish the relationship between the tables. Okay. So coming to what are these dimension attributes is, so the various columns present in the dimension tables are referred to as the dimension attributes. We call the columns present in the dimension table as dimension attributes. There is no. So there is no limit on the number of dimensions. They can be any number of dimensions. So a fact table can have any number of dimensions. So these are all the points related to a dimension table. Is this dimension table clear? So what this dimension table will contain is, it will contain the details of the transaction tables. Okay. So here if we see, here in this table all the transactions will be present, and this product table will be a dimension table. So dimension in the sense it will have the details. So what, this product, we are not maintaining any details of the product in the transaction table, we are maintaining the product details in the separate table. This is the product table. So this product table which contains the details is called as a dimension table. So easy to identify a dimension table is which is having a details. So whenever a table is having the detailed explanation of anything, that it is said to be a dimension table. So the dimension can also contain one or more hierarchical relationships. So what is meant by that is we'll be seeing in the further slides. I mean the further topics. Dimensions offer a descriptive characteristics of the facts with the help of their attributes. That is what I have told you. So dimension tables contains the details. So these details describe the characteristics of the facts. Facts in the sense a transaction. Okay. So is the concept of dimension table clear? Simply, dimension table is a table which contains the details, descriptive characteristics of the fact tables. Fact tables in the sense the transaction tables. Okay, is it clear to everyone? Okay.
Yeah.
If-
Yeah, yes, yes, Ram.
yeah. So coming to fact tables. So I have told you, since as I have told you that fact tables contains the transactions, whereas the dimension tables contains the details of the transactions. So what is the need for differentiation is, if you maintain all the transaction data in a separate table, it will be good for analysis. So if you maintain all the transactions in a one table, it will be good. I mean, it will be easy for us to perform the analysis. You can perform the calculations of the fact tables, like if you can do sum, min, max. So you can perform those aggregations on that fact tables. It will be easy for us to do any analysis if you maintain all the transactions in a single table and all the descriptive characteristics in the other table, which are called as the dimension tables. So what are these fact tables is, fact tables contains the measurements. Since I have told you this transactions, so transactions contains the measurements, metrics and facts about the business process, while the dimension table is the is a companion to the fact table, which contains the descriptive attributes to be used as query constraint. So that's what I have told. So all the transactions like measurements will be present in the fact table, and the descriptive characteristics will be present in the dimension table. So so whenever we do this data modeling, what happens is, so the fact table will be present in the middle. So again, there will be three types of schemas. So whenever you're performing this data modeling, so this is how, using these three, one among these three schemas, you will design your dimensions and fact tables. So there are three types of schema, but in all these three types of schema, fact table will be present in the middle. See, fact table will be present in the middle, and the fact table will be surrounded by the dimension tables. Okay. So this fact table is located at the center of star or snowflake schema, and the other one is the galaxy schema. So all these three, all these three schemas, the fact table will be located at the center of the schema, whereas the dimension schema is located at the edges. So it will be located at the edges. Fact table is defined by their grain or its most atomic level, whereas the dimension table should be what. So I have told you that this fact table will be basically having all the metrics, whereas the dimension table will contains the descriptive things of that fact table. So fact table helps to store the report labels, whereas the dimension table contains the details data. So all these are repeated points only. Fact table does not contain any hierarchy. So what do you mean by that hierarchies? I'll tell you. Whereas the dimension table contains a hierarchy. So example, so this is how. So if you take a sales fact, wherein all the transaction data will be stored in the sales. So whenever a transaction gets created, so what does this transaction contains? It contains a quantity, what is the amount. So all this we made, product ID, all this we will be maintained in the sales fact. So customer id will also be maintained. So what happens is, this fact will be linked to this dimension with the help of what. So how will you establish the relationship between the tables? Using what? I have explained it
Foreign
now.
keys.
Yeah.
Foreign keys.
Yeah, primary and
Yes,
foreign.
using foreign keys. So this is how it looks. Fact will be present in the middle, and these are the dimensions. So what are the examples of dimensions? A customer. So whenever you take a customer table, it will contain all the details of the customer. So that is why this customer table will become a dimension. And if you take a product table, it also contains all the details of the product. So that is why this is a dimension table. And similarly, likewise, this location, branch, date. All these are the dimensions which are surrounding a fact. That is the sales fact here. And coming to this types of, so whenever you are creating this this facts and dimension tables, you there are three ways in which you can create this dimension models. So what are these three are? Star model, you can call them either as models or schemas. So the first one is star, second one is snowflake, and the third one is hybrid schema. So what happens in the star schema? So what happens in the star schema is the fact is surrounded. So here the fact will be surrounded by all the dimensions in the star schema. So whenever you are modeling your database, what you need to first know what are all the dimensions. You should define what are all the dimension tables. Then you should define what are all the fact tables, and then you need to combine this, establish the relationship between the dimension and the fact tables. So in the star schema, what happens is, as I've told you, fact is surrounded by all the dimensions. There is only fact to dimension relationship. There is no relationship between the dimensions. So here, if you can see you can see in this diagram that only fact to dimension, only fact to dimension relationship is present. So dimension, these two dimensions cannot establish, we can't establish relationship between these two dimensions. Only fact to dimension relationship is present. So that is star schema. And the next schema is the snowflake schema. So what is the snowflake schema is, here the dimension to dimension relationship also is possible. Whereas in star schema, what happens, only the fact and dimension can establish a relationship. But in snowflake, we can also establish the relationship between the one dimension to other dimension also. So that is the difference between the star and snowflake schema. So here, see it can be compared to a snowflake symbol. So here if you see, these flakes are combined to each other. In the same way, this dimension to dimension relationship is there. So that is the significance of the name, the snowflake. Whereas in the star, these are different. So one dimension cannot meet the other dimension, but in snowflake they can meet. Here we can see. Okay, is it clear? So they'll be asking you, like what are the types of schemas in dimension modeling, and what are the dimension models. So then you should tell them that we have three types of schemas, or three types of dimension models. So what are those? Is star schema. In star schema, we'll have the fact surrounded by all the dimensions, and there is no dimension to dimension relationship. Only fact to dimension relationship exists. And also, when we compare this both star and snowflake schema, what happens is the star schema is more efficient. They'll ask you which one is more efficient. So star schema is more efficient. Why? Because it has only less joins, since dimension to dimension relations are not present. So if you want to again combine these dimension to dimension, what you'll do, for while querying, you need to write the other join condition. So here we need not write the other join conditions, because we are not having many relations, like these dimensions are not in a combined state. But when we take this snowflake schema, here these two dimensions are related to each other. So that is why if you query this schema, what happens, you need to write multiple join conditions. Whereas in star schema, we'll be writing only a few join conditions. That is why this star schema is more efficient. Okay, again I'll be asking you in this tomorrow class, like which is the more efficient and why. You should be able to tell me. So this is the example. See, I have told you, someone have asked me like, what is this foreign key? See, this is the sales fact table. So these are all the keys which are present here, and these are all the dimension tables. So if we take this item dimension as an example, so instead of maintaining all these columns once again in the sales fact table, what are they doing? They are selecting the primary key in this dimension table and taking this primary key and putting in the other table. So the column of other table is coming to the another table. So the primary key or column of one table is going to the another table. So what will this become here? It will become a foreign thing. So that is why they have named it as a foreign key. So using the foreign key, they'll establish the relationship between all these things. So whenever if you want details of any transaction, I mean item details of any transactions, you will combine, you will write a joint query which will join this table with this table and extract all the information necessary for you. Okay, so coming to this, the other one schema is the hybrid schema or galaxy schema. So it is the combination of Snowflake and star schema. So basically they'll be asking you like what is the schema which is being used in the project. So few will be using star schemas, few will be using Snowflake schemas, few will be using both the schemas, few projects. Okay, is this clear?
I see.
Yeah.
So which is the most efficient one? Is it star or Snowflake?
Star.
Star.
Why?
Having less relationships
Yeah, so
due
you
to
need not write many join conditions because it has only less relationships. So hybrid schema, it is a schema. It's a combination of both Snowflake and star schemas. Yeah, the example of the Snowflake schema is see here. So what is we have? What are we having? We are having this sales fact table, and here there is an item dimension table, and here this dimension table is again connected to another dimension table. So using supplier key we are establishing the relationship between these two tables. So here if we can see in the location dimension table, so we are maintaining a city key, and we are having the other dimension table, another dimension table. So this is the Snowflake schema. So in star schema will be having only dimensions. So this is what it is meant by the hierarchy. So somewhere we have seen that, see if we see here, dimensions are having hierarchy. So this is the main dimension and this is the sub dimension. So this this concept of hierarchy cannot be maintained for the fact tables. So this hierarchy concept can be maintained only for the dimension tables. So coming to the types of dimensions. So what are dimensions? What is a dimension table? Single word answer.
the details of
Yeah.
Description.
transaction
Description details. Yes.
descriptive headings.
So again, these
Link.
dimension tables are categorized into these are tables. So let's learn about what are these dimensions. So first one is junk dimension. This dimension is present in big projects. So whenever you have a big project, you can see a one table will be a junk dimension table. So when you can call it a big project is, so if your project has 100 or more tables, then you'll have this one junk dimension table. So what is this junk dimension table is? So if you consider this junk dimension table as an example, you can see, so how many ever columns you have in this table, they'll be having only two values. See, if you take each flag one, so yes or no, only two values. So active or inactive, like this. So how many ever columns you have in a table, all these columns will have only two values. The values will be only two. So like active or inactive, male or female, correct, wrong, zero, one, yes, no. So how many ever columns you have, all these columns will be having only one among these two values. So why when this junk dimension gets created is, if you have more flag columns in your fact tables, we will remove all those flag columns from that fact table and keep it in the table called as junk dimension table. So this is how the junk dimensions are created. How are they created? So whenever you have more flag columns in your fact tables, they'll remove all those flag columns from that fact tables, and they'll be creating a table called as junk dimensions. So how many ever columns you have in this junk dimensions, the values for those columns will be only two, one among those two. Okay, is this clear? What type of columns does this junk dimension contains?
Just like yes or no times. Yes or no, active, inactive. Like this.
Yeah, flag columns will be
Flag.
present in this junk dimensions. So how many ever columns they might be present, the values will be only two. So here you can see yes, no, like that only. Inactive, active, these are the examples. So what will they do? They'll remove all the flag columns. See, they'll remove all the flag columns, they'll keep here, and they'll maintain only a single column here, and they'll establish a relationship using that single column to this junk dimension. Clear? No, everyone? Is it clear to everyone? What are those junk dimensions?
Yes.
Yes, thank you. Yeah.
So coming to this conform dimensions, so few, there'll be a few conform dimensions in your project. So what are these conform dimensions? Is a dimension is said to be a conform dimensions when it is used, when the same, if a same table is used by the multiple facts. For example, if you take this picture here, you can see product table is used with this sales fact, and the same product is used with this inventory fact. So here the same dimension table is connecting with the different facts, so that kind of tables are said to be the conform tables, conform dimensions. A conform dimension connect to multiple facts. Okay, so here when a same table is connecting to the different facts, so that kind of dimensions are said to be the conform dimensions. Is it clear?
Yeah.
Is it clear? Yeah. So coming to this degenerate dimensions. So for example, if you take this invoice, so we can see we can will be having the invoice tables. Anyone working on this retail domain, they can see this invoice, and also in other domains also this invoice will be present. So for example, if we take that invoice, so what happens, we do not have a table called as invoice. It will be subdivided into two tables. One is invoice header and other is the invoice line. So it is invoice header and the invoice line. The header table, I mean, the invoice header table will only have the invoice information like invoice number, customer number, supply number, warehouse number. So all this invoice information will be maintained in the invoice header table, but it doesn't have any quantity or amount field. So quantity and amount, this measurement fields will be present in the invoice line table. Okay, this invoice line will become a, since it has the measurement columns, so this will become the fact tables. Okay, so invoice, whenever you are storing the invoice details, what happens is they want all the invoice information. Invoice so if you see an invoice, if you see an invoice receipt, so what, all the information will be present in that invoice receipt. So but all those information present in that invoice receipt will not be stored in a single table. It will be divided into two tables. So one is the invoice header and the other one is the invoice line. So in invoice header, all the invoice information will be present. I mean, it's like details related to that invoice, like invoice number, customer number, all those will be present in the invoice header table, and the amount, quantities, so measurement fields, all those will be present in the invoice line table. So that invoice line table is called as. So
Degenerate dimension.
any doubts? Is anyone speaking?
Yes, yeah.
Yeah, any
Yes,
doubt?
yes. No, nothing. Sure.
Yeah, 1 second. So I have told you that whenever you're storing the invoice information, you will be dividing those again into the two tables. One is the invoice header table, which contains all the detailed information, and the other one is the invoice line table, which contains the quantity information. So what is happening here? In invoice header, we don't have any measures. I've told you all the measures like quantity and amount will be placed in the invoice line table. So this invoice header, again they are telling that this invoice header is a, actually if you see that, basically this invoice contains all the details. So whenever invoice, in the sense it's like a transaction, whenever you do a transaction you'll be getting this invoice. So actually it should be a fact table, but they consider this as this invoice header as a dimension table. So here what is happening, they are degrading the property of a fact table. So that is why it is called as a degenerate dimension. The data related to the transaction, the data is related to a transaction. So when is an invoice, I mean, when do you get an invoice? So whenever you do a transaction, you will get this invoice. So the data is related to the transaction only. But even if the data is related to transaction, you are telling that as an dimension table. So what is having, but actually the property of a dimension table is the descriptive. It will tell us the descriptive characteristics of a transaction. But still, the even if this invoice is related to a transaction thing, but still you are calling this invoice as a dimension. So what is happening here? We are degrading the properties of a dimension. That is why these are called as degenerate dimensions. See, you can once go through this in order to get what I have told you. So you want me to read this or okay? So if anything, if it is
Okay.
yeah, if it is degrading a property of a dimension, then you call those types of dimension tables as degenerate dimensions. And coming to this rapidly changing dimensions. So, if the data present in this table changes frequently, then that type of dimension is called as the rapidly changing dimensions. For example, if you take this customer table comes under what? Is it a fact table or a dimension table? Customer. So, customer table contains all
Dimension.
the details of the customer. Is it a fact or a dimension table?
Dimension,
Yeah. So, why a dimension? Why are,
because
how are you?
details about the customer.
It
Yeah.
is a primary one.
It is containing the details of the customer. So there is a probability that the details of a customer changes frequently. So customer, of course their name won't change, but the city where they stay, the state, their age, their income, all these are mostly they'll be changing frequently. So any kind of dimension which is holding a data which changes frequently is referred to as a rapidly changing dimension. So as the name specifies, you can see rapidly changing. So the changes happens frequently and fastly in the table. So such kind of dimensions are referred to as rapidly changing dimensions. Okay. So coming to this role play dimensions. What are these role play dimensions? For example, if you take a man. So man, for his children, he'll be a dad. For his parents, he'll be a son. For his wife, he'll be a husband. So what is happening here? The man here is a single person, but he is playing different roles. So such kind, the same concept here is the role playing dimensions. What happens here is, so here we'll be having a single date. So single date dimension. So here timetable is a dimension, but this time, if you combine this timetable with the shipment table, it becomes ship date. If you combine it with some sales table, it will become sales time. So the table with which this dimension gets combined, based upon that, the role it is playing is differing. So those such type of tables are called as role playing dimensions. So based on what table it is getting combined to, based on that combined table, the role which that dimension plays differ. So such type of tables are called as role playing dimensions. Whenever this timetable is combined with shipment table, it acts as a ship date. So in such way, so simply the same concept which I have told you in an example. So coming to the shrunken dimensions. So what are this shrunken dimensions are? It is a subset of the existing dimension table. So instead of made, see here we are having a time dimension table. So what are the shrunken dimensions? We are again subdividing this dimension table into year, quarter, month, week. So what we are subdividing these tables. So these dimensions are called as shrunken dimensions. So a shrunken dimension is a table which is referred to as subset of the alternative dimension. So all these subdimensions are called as the shrunken dimensions. So this is very important. See, this has been asked in 3 4 interviews which I have attended. So they'll be asking you. They won't directly ask you like what do you mean by this infer dimensions, but this concept is important. They'll ask you like early coming fact or rate arrival dimensions. So what is this explain? So what are these so what is this early coming fact and what is this late arrival dimension? Let's see with an example. So if you take an example of something, uh, this Ola electric bikes. So what happened in when they have released that? So initially, what they did before they have released that product, Ola bike into the market itself, they have started the sales. So how will pre-book those bike? So even before the product has been introduced into the market, we are getting the orders for that product. We don't even know how that product, I mean, we just know the look of it, but we don't know the internet details like what is the engine being used and all. Even before getting all the details of that product, we are prepaying for that product and creating transactions for it. Okay, so early coming fact. So what is happening here? A transaction is being created before itself that product got created. So your product is not ready, your Ola scooty itself is not ready, but still you are booking a scooty. So what happens? You are booking a scooty before itself. That is before your scooty has been prepared, you are booking a scooty. That is, you are creating a transaction for it. But see, so if we take an example, instead of this promo code, let's consider this as a product. So what happens here? If we do not know like what is that product, but still a transaction, we are pre-booking for that product. So what happens here is a transaction gets created before itself, but you do not have those product details here. See, yeah. So, for example, if you consider this example only, here we are having fact table as tickets, and the dimension table is promo code. So here, if you see a transaction, that is, you have already bought a ticket. For that ticket, so once you buy a ticket, you will a transaction gets created in the fact table. So you'll buy a ticket, but you're not aware of like what is the promotion type and what is the discount type. You're not aware, but still you got this transaction. So in such cases, what they'll do is, if we take this Ola thing only, what happens? You are pre-booking and a transaction is getting created in the fact table, but you're not aware of that product details. So what they'll do is, for whichever you are not aware, so whichever details you're not aware, they'll be maintaining a separate value. So they'll be maintaining some default value. So if it belongs to a certain category, they'll give some value. If it belongs to some other category, they'll be giving. So for whichever columns you don't have any defined details, they'll be maintaining few constant values. So once your product is ready, then you'll get the details of those products. Then they will replace all those constant values with the actual values. So what happens after the product get ready, then you will get the actual values. So what, this is the meaning of late arrival dimensions. So dimension contains the details. So when are you getting the details of the product? After you do a transaction, later when the product is ready, that time you are getting the details of the product. So late arrival, the dimensions, the details are arriving late. But early coming facts, the transaction is getting created before itself, but the details of the product are coming late. So that is the reason this inferred dimensions are called as early coming facts or late arrival dimensions. Did you understand this? Did you guys understand
Yes, thank
this?
you. Yeah.
Everyone?
Yeah, yes, Shishira.
Satish, Mani, Mike, Purushottam, Ravi, I know you know all these things. TB, Shakti, Midun, did you guys understand it?
Yeah, we got it.
Yes.
Yes.
Yeah. So
Yeah,
whenever
yes,
a transaction is getting before, yeah, transaction is getting created before itself, you are getting the details into the dimension table. Then those types of dimensions are called as inferred dimensions. So in this inferred dimensions, the facts will be coming early. That is, the transactions will be created before itself, but the dimension details, that is, details related to the any product, will be arriving late. So coming to the static dimensions, so definitely there will be a static dimension in your project. So they'll be maintaining this table wherein they'll be maintaining the source name. So what are all the sources you are having? So in this table, what do you mean by static table is, you won't be having any source of the data. Here in this table, you will be manually entering the details. So like source, so these all you'll be entering manually. So for the dimensions which you don't have any sources, the dimensions which do not have any source of data are called as static dimensions. In this static dimensions, we will be entering the data manually. Okay, coming to the types of facts. So all these are clear now. Once again, I'll revise once we complete this fact tables. So coming to the types of facts, so there are five types, six, yeah, five or six types of fact tables. We'll be completing it fastly only. So additive facts. So additive facts, whenever you can perform any aggregation functions like sum and average on the table, then they're called as additive facts. So if you have a table, so on the table you can perform the sum and average, like any aggregations, any aggregate functions on the table, then that fact table is said to be an additive fact. And semi additive fact is, so when you combine this fact table with the dimension tables, so after you join both those them, so only few dimensions can be added up. So for example, if you combine a customer table with the sales sales table. So let me explain this with this example. So here if you see, if we combine this fact table with the customer table, so based upon the customer, for example, Sisira and sales of Sisira. So we can add all the sales of Sisira based upon the customer. So what you'll do, where Sisira, then add of quantity and amount. So you are able to perform the aggregations based upon the customer name. So you can also perform the aggregations. So product, and you can combine this product with the sales fact table, and you can perform the aggregations. And also to the branch, based upon the branch. So in the branch, how many sales has happened? So in Hyderabad branch, how many sales have happened? So you can combine both this and perform the aggregations. So if you are able to combine both this and perform the aggregations, then those are additive facts. But only if only few dimensions you are able to combine with this fact table and perform aggregations on them, then those are said to be the semi additive. So for only the few fact tables you will be able to perform the aggregations. And coming to non-additive facts, so whenever you combine these fact tables with the dimension tables, you won't be able to perform any aggregations. So such types of facts are called as the non-additive facts. So you can't combinedly perform the aggregations. After you join the fact table and the dimension table, you cannot perform combined aggregations on them. So such type of fact tables are called as the non-additive facts. So coming to transaction facts, that's what we were discussing. So this transaction fact tables are the fact tables which contains the transactional data. So cumulative facts are, so what kind of data is present in this cumulative factors? The cumulative data will be present here. So whenever you add the data into this, it gets cumulative, it gets added up, and then you will be keeping in this table. So whenever you combine the data, what does what it defines what has happened over a period of time. So summed cumulative, what is the meaning of cumulative is summed up. So summed up values will be present in this cumulative fact table. And coming to the snapshot table, it has the snapshot info. So what has happened this week, so what has happened this month, so what has happened this quarter, what has happened this year. So weekly, monthly, quarterly, yearly, this information, snapshot of week, snapshot of month, snapshot of quarter. So the snapshot information will be present in the snapshot fact table. Okay, are this clear? So these are very important, uh, especially this infer dimension. So you can tell them with the help of that Ola, which I have told you, Ola bikes. So this concept is very important in interview perspective. Okay, are these concepts clear? So once again, these are somewhat few of them are somewhat difficult to understand. But once you go through all the definitions and so, then you will be able to understand them clearly. And the slowly changing dimensions we are further classified into SCD type 1 type 2. So we'll be discuss them separately whenever we are doing practicals of that SCDs. Then we'll be discussing that concept and doing the practical. Okay, is it clear for everyone? So once you go through this video again, see the slides and definitions of them, then you will be getting more clarity on it.
Yeah, it's clear to me. Thank you.
So any doubts?
Uh, Regarding that infer dimension, right? The infer dimension mean we need to split into two table or the two
Yeah, let me tell you.
In pre-booking, we'll maintain in one dimension and that.
Yeah, yeah. Where is that? Yeah, yeah. Yes. So this dimension, see, I have explained you the concept that we'll be having a fact table and the dimension table. But the dimension table in which the data is coming slowly, that is lately, that table, the dimension table is referred to as inferred dimension table. Okay. So if you take the Ola product table, so Ola, they do not have the product specifications. You will get you are getting that product information after that Ola scooty manufacturing has been completed. So you are getting the details of that product after the completion of its manufacturing. So the details which are entering into this dimension table are late.
Okay.
Okay. Yeah. A dimension table in which the details enter lately.
Yeah, you can say update later.
Yeah.
I got a question, Cecira.
Yeah, Ravi.
Um, Meaning, like the data warehouse, it is on the overview. It is like a database with tables of different structure. Uh,
Yes.
that's basically say for example, that's right. I mean, like if we got two databases, one is a data warehouse model and one is a regular database. How do
Hmm.
you differentiate how do you identify without getting into the database itself? I mean, like say for example, uh,
See, you can differentiate it based upon the uh, data you maintain. As I have told you, this database will be data warehouse will be maintaining the historical data, and also if you have dimensions and fact tables, simply you can look at the names. So they'll be
uh,
maintaining this naming conventions, no? So
yeah,
if it has dimensions, yeah.
not everyone does the same thing, right? Say for example, if there are 10 fact tables and 100 dimension table, they don't put the schema fact or the dimension. If they don't do that one, say for example an old data warehouse who don't have much experience in this one, and then they created just basically normal table names and
So
kind of stuff. How do
it
you be
won't happen in a real time scenario, no, Ravi. Everything will be
Mhm.
having a naming conventions and yeah.
Of course, naming conventions, but not everyone designed by using easily identifiable names. For example, fact or dimension, dim, etc. Is there any way, like I'm just trying to figure out based on the database properties or anything? Could we figure out like whether it's data warehouse or anything? Or
Yeah, yeah. So based on these properties, so definitely you need to look upon the system, no? Even before knowing the system, how will you come to know whether it will be a database or a data warehouse?
okay, in that case, like when we are discussing this Synapse, the other day I asked a question. You said Synapse is used for data warehousing.
Yeah.
But can we not use Synapse for a normal storing of data without the data warehousing concept?
See, it's not like that. It's like it depends on a project to project. So if you take all the historical data and keep it into Synapse, so
Can we not put OLTP data onto Synapse?
you can put OLTP data onto Synapse, but the basic purpose of a data warehouse is not to. So, what is the basic purpose of a data warehouse?
Analysis on the
Yes.
history.
Yeah. So, why do you maintain this OLTP and OLAP separately?
Some doesn't, right? I mean, like if everyone, some doesn't maintain
Yeah. Yeah,
OLTP
yeah.
and
Some
OLAP
doesn't.
separately, but they also use the analysis on the same OLTP. Of course, it runs slow. It's a different story.
Yeah.
Um, But yeah,
Yeah, but yeah, there is no way that you can directly see and tell that it's a data warehouse and it's a thing.
okay,
So yeah, yeah, definitely you have to look into the tables
to figure out.
and
Okay,
a
fair
few
enough.
other yeah, these are all the properties you can use to figure out whether it's a database or a data warehouse.
Okay, okay.
So any other?
No, not for me. Thank you.
Any doubts, anyone? So Ravi, see, so every project, it depends upon the organization to organization and again project level. So each project will be maintaining their naming conventions and the architecture will be different.
Yeah.
So yeah, once you get the KAT, you'll be knowing based upon the naming conventions and the other factors. You then will be able to differentiate like what is a database and a data
Okay,
warehouse. Yeah.
okay, okay, okay. Fine, fine.
So then if everything is fine, then yeah. Okay, guys, that's all for the day.
And
Any doubts?
just
Are we good
just
to
one
close?
second before you go off. One
Yeah.
second before you go off. Like, what we going on for tomorrow? Just a quick overview. Uh,
Tomorrow, yeah. So I think now we are good to create a pipeline.
okay, we're
So
done with the integration on times and everything. So we going with pipelines tomorrow, right? I mean, like practical tomorrow.
yes, it's a practical
Okay,
thing.
okay, okay. Fair enough. Yeah.
Mostly, or else if as far as I remember, we have covered all the concepts which are necessary for us to start going with the pipeline creation. So if there are any pending things, I'll be covering them and then we'll be creating our first pipeline tomorrow.
Oh, perfect. Thank you.
Yeah. Okay, guys. Have a good day. Good night. Bye.
Good day.
Take care.
Bye.